In today's lesson, we'll be learning how to check solutions. You should already know that the solution of a linear system, which is just two lines, is also called the POI, or point of intersection. You can solve a linear system by graphing, substitution, or elimination. And by solve, I mean find the point of intersection. In our first example, we want to use a left side, right side check to determine if 4, 9 is a solution of the linear system. So basically, we want to know if that coordinate is the point of intersection of these two lines. The first equation is 3x minus 2y equals negative 6, and the second equation is 2y plus x minus 22 equals 0. I'm going to start by rewriting the equation of equation 1, which is 3x minus 2y equals negative 6. Exactly is left side and right side. Well, left side and right side is relative to the equal sign. Therefore, this would be considered the left side, and this would be considered the right side. And we want to make sure that both sides are equal once we substitute in this point. Let's go ahead and substitute in this point. I'm going to say sub 4, 9. That means I'm going to replace x with 4 and y with 9, and everything else stays the same. So over here, instead of writing x, I'm going to write 4, and over here, instead of writing y, I'm going to write 9, and everything else stays the same. I need a little bit more space. So 3 multiplied by 4 is 12. Negative 2 multiplied by 9 is negative 18, and this negative 6 stays the same. 12 subtract 18 is negative 6, and the negative 6 on the right side stays the same. Now you'll notice that the left side is equal to the right side. So I'm going to make a concluding statement. Therefore, left side is equal to right side, which means this point lies on this line. However, we need to check the other line as well. We want to see if this point lies on equation 2. We're going to use the exact same steps as the previous slide, except we're going to do it for equation 2. So we're going to do a left side, right side check with the coordinates 4 and 9, and we're going to use equation 2. Let's rewrite equation 2 to start. 2y plus x minus 22 equals 0. This is considered the left side because it is left of the equal sign, and that is considered the right side because it is right of the equal sign. At this point, we want to substitute in our coordinate, so I'm going to say sub 4, 9. All right, so I'm going to replace x with 4 and y with 9. Everything else stays the same. So instead of y, I'm going to write 9. Instead of x, I'm going to write 4. The negative 22 stays the same, and the equal 0 stays exactly the same as well. And let's move this up to create more space. 2 multiplied by 9 is 18. This plus 4 just stays exactly the same. I can remove it from the brackets because nothing's really being done to it. The negative 22 stays the same, and this 0 stays the same. At this point, you're going to have to simplify. You can use a calculator or mental math. 18 plus 4 is 22, and 22 subtract 22 is 0. As you can see, both sides of the equal sign are equal. So I can say, therefore, left side equals right side. And let's make a final concluding sentence for both of these slides. I'm going to say, since left side equals right side for both equations, Therefore, 4, 9 is a solution of the linear system. Basically, that means 4, 9 is the point of intersection. And let's just zoom out to show you all the work that was needed for this one question. In our second example, we want to use a left side, right side check to determine if the coordinate 3, 1 is the solution of the linear system, which is listed below. So I have equation 1 in red and equation 2 in blue. I'm going to start with equation 1. We want to rewrite that equation, y equals 3x minus 8. If you recall, this is considered the left side, and that is considered the right side. I want to substitute in this coordinate of 3, 1 and see if the left side is equal to the right side. So let's say sub 3, 1. Now, instead of writing x and y, I'm going to write 3 and 1. So over on the left, I have a y. Instead of writing y, I'm going to write 1, and I'm going to put that in brackets. Now, instead of writing the x, I'm going to write 3 in brackets. And this negative 8 stays exactly the same. Don't touch it. And let's create more space for ourselves. So this 1 stays the same. Nothing's happening to it. So I can take it out of the brackets. 3 multiplied by 3 is 9. And the negative 8 stays exactly the same. So let's simplify this a little bit. 9 subtract 8 is 1. The left side is equal to the right side. Let's make a concluding statement there. Therefore, left side is equal to right side, which means this coordinate lies on line number 1. But we need to check if it also lies on line number 2. At this point, we're going to do the exact same technique for equation 2. We're going to do a left side, right side check with the coordinate 3, 1. And we're going to do it for the blue equation. So let's begin by rewriting our equation. 2x plus y equals 9. Again, anything to the left of the equal sign is considered the left side, and anything on the right is considered the right side. What I want to do now is I want to substitute in this coordinate of 3, 1, and I want to see if the left side is equal to the right side. So I'm going to substitute in my x and y values. Instead of writing x, I can write 3. And instead of writing y, I can write 1. And the equal 9 stays exactly the same because I haven't done anything to it. So let's go ahead and simplify some of these numbers. 2 times 3 is 6. This 1 stays exactly the same. And this 9 stays exactly the same. Okay, so 6 plus 1 is 7. This 9 stays exactly the same. But wait a minute, 7 equals 9? These two numbers are not equal. So I'm going to put a cross through that equal sign, which means left side is not equal to right side. So I'm going to write this. Therefore, left side is not equal to right side. Let's make sense of all this information. So I'm going to say, since left side was not equal to right side for both equations, therefore the points 3, 1 are not a solution for the linear system. This basically means that the coordinate 3, 1 is not the point of intersection.